Assalamu alaikum students. Today our topic is regarding Rydberg formula. What is Rydberg formula? Now as we are aware that whenever the electron de-excites from higher energy orbit, if I will make a model here, this is the nucleus of an atom having positive charge. This shell number first having electrons, this shell number second, and so on and so forth. Now, wherever according to Bohr's model, whenever electron de-excites from higher energy orbit to lower, first if it is in the lower energy orbit, it first absorbs energy, then goes up. Of if it is here, it absorbs energy and goes up. So once we heat it out, the electrons in the respective shells goes higher and higher. But so they have to absorb energy. Once the electron in the excited remains in a very small for a small time, and in the excited state it comes down. Once it comes down and it radiates, it gives energy, radiation in the form of HNU. So the hydrogen, we have to read related hydrogen. Actually, we have to read about the line spectra of hydrogen atom. According to Bohr, we are aware, what we are aware, that energy radiated. According to Bohr, energy emitted is given by E equals to EI minus EF. What energy given? I am saying energy emitted when the electron comes from higher energy orbit to lower energy orbit. The electron in this orbit is having particular energy. The electron in this very orbit is having particular energy. So I here write it down E equals to EI minus EF, where EI corresponds to Ni energy level. Ni EI is the energy associated with the principal quantum number Ni, and EF is the energy associated with the energy level for which principal quantum number is Nf, such that such that Ni is greater than Nf. Once Ni is greater than Nf, then the energy in the Ni level will be less negative, that is a bit positive as compared to this. So as this is, let's suppose this will be some Ni and this will be some Nf. So this is having a bit higher energy as compared to this. It's having more negative, this is having less negative. So energy emitted is given by energy of actually emitted photon is given by E is equal to EI minus EF. Or we can place E. E is H into nu minus EI equals to EI minus EF. But we are aware of the fact, but E energy associated with the nth orbit equals to what? Minus m e raised power 4 over 8h square epsilon naught square n square. This is the energy associated with the nth orbit. So we can here use it in the above equation. H nu equals to EI, we can put it minus m e raised power 4 over 8 h square epsilon naught square n I square. Why Ni? Because Ei is the energy associated with the energy level for which Ni, for which principal quantum number is Ni, and Ef minus of minus of minus what Ef will be m e raised power 4 again over 8 h square epsilon naught square nf square. Why nf? Because instead of n I put nf because ef is the energy of that very energy level for which principal quantum number is nf. So we can, which implies h nu equal to this minus minus plus, it is going to come first, 8 h square epsilon naught square nf square minus m e raised power 4 over 8 h square epsilon naught square ni square, or m e raised power 4, m e raised power 4, 8 h square epsilon naught square, 8 h square epsilon, those are common, so let's take them common. Then it will become as like this: h nu equals to m e raised power 4 over 8 h square epsilon naught square. So inside what will remain is 1 over nf square minus 1 over ni square. Just put some equation second, let this was equation first. But wherever, but c, there is a relationship between c, nu and lambda, frequency, speed of light, as well as speed of radiation, as well as the wavelength. So we can place here nu equals to c by lambda. C is equal to nu lambda, where nu is frequency, lambda is the wavelength of radiation, nu is equal to c over lambda. So replacing this very nu which we are having here, h nu, h, this very nu, we will replace it by c by lambda. Then what will be having? H, we will having h c over lambda equals to m e raised power 4 8 h square epsilon naught square 1 over nf square minus 1 over ni square. So this h is going to multiply here, this c is going to come down, what will remain there? 1 over lambda equals to m e raised power 4 over 8 h cube epsilon naught square into c, or within the brackets we are having 1 by nf square minus 1 by ni square. This very m is constant, e is constant, h is constant, epsilon naught, and c is the speed of light. Everything there is constant. So we can place this equation as 1 over lambda equals to rh, 1 over nf square minus 1 over ni square. What is now nf and what is this rh? Where rh is equal to m e raised power 4 over 8 h cube epsilon naught square c, and is known as Rydberg constant. Rydberg constant, and its value is equals to 1.097 into 10 to the raised power 7 per meter. 1.097 into 10 raised power 7 per meter. So we can, this very constant, this rh is called m is called a Rydberg constant, and this is called as Rydberg formula. Or you can simply place it 1 over nu 1 over lambda, that is written as nu bar is equal to rh 1 over nf square minus 1 over ni square, where this is called as wave number, that is number of wave number of waves per area. So this is related to the formula, Rydberg formula, where this is called, where lambda is wave number of waves in unit distance, number of waves in unit distance you have to remember about. And this very formula is called as this very formula, or this very formula, both are called as Rydberg formula. Rydberg formula, where nu bar is called as wave number, that means number of waves in unit distances, how many waves are present in unit distances. or simply you have to remember wave number, or you have to remember this very equation or this very equation. For the examination perspective, you have to understand, you have to remember this very equation, so that in future the numericals will come from either this at that, and you have to remember this. You don't have to remember for calculation purposes, you have to remember all this. This all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.